So our first question is, in 1 second a particle goes from point A to point B moving in a semicircle of radius 1 meter. We have to calculate the magnitude of average velocity. So here particle is moving in a semicircular path like this. From point A to point B, and we have to calculate the magnitude of average velocity. The radius of this circle is given as, that is r is equal to 1 meter, and the time period to move the particle from point A to point B is given as 1 second. So now we will see that the average velocity is defined as the displacement, net displacement over net time. That is average velocity is defined as net displacement divided by net time. So here displacement between the 2 points A and B, that is defined as the minimum distance between the 2 points is 2r. So here displacement, magnitude of displacement will be equal to 2r, that is 2 into 1 meter, that is equal to 2 meter. So we will use this formula and we will calculate the V average, that is equal to net displacement in 2 meter divided by 1 second, that is equal to 2 meter per second. So this is our answer. Now our next question is, a particle is moving eastwards with a velocity of 5 meter per second, and after 10 seconds the velocity changes to 5 meter per second northwards direction. So here we have to calculate the average acceleration, and also we have to calculate the direction of this average acceleration, particle with which it is moving. So okay, so our second question is, we will draw the directions first. So this is our north direction, this is our south, this is our west, and this is our east. Initially at t is equal to 0, particle is moving in this direction with velocity u is equal to 5 meter per second. So u is equal to 5 meter per second, and after 10 seconds this particle is moving in this direction northwards, that is v is equal to 5 meter per second. So I will define in the Cartesian coordinate system these directions as, this is our y-axis, this is our x-axis. So initially particle is moving in this direction, that is u vector is equal to 5 meter per second I cap. Also after t is equal to 10 seconds, this particle is moving in this direction, that is v vector is equal to 5 meter per second j cap. Now the magnitude of this average acceleration is defined as a vector of average acceleration is defined as final velocity vector minus initial velocity vector over total time taken, net time. Okay, so here our v final is 5 j cap and v initial is 5 I cap divided by t is equal to 10 second, that is 10. So from this we can calculate the magnitude of this average acceleration, that will be equal to a average magnitude is equal to magnitude of this vector v final minus v initial divided by this time. So magnitude of this vector will be magnitude of this vector will be root under 5 square plus 5 square divided by 10. So our average acceleration magnitude will be equal to, this will be root under 50 divided by 10, that will be equal to, we can write it 25 multiplied 2, that will be equal to 5 root 2 divided by 10, that is equal to 1 by root 2 meter per second square. So this is our magnitude of average acceleration. Now how we will calculate the direction of this average acceleration the particle will be having. So we will use the vector summation method. From this equation, the direction of this average vector, average acceleration vector, will be the direction of this vector. Like the first vector is in the y direction, that is the magnitude having 5 meter per second, and 5 meter per second divided by 10 meter per second square. And the second vector is negative v I cap divided by t, that is negative 5 by 10 meter per second square. And now we know that what will be the direction of this a average, that will be equal to direction, we can take any triangle now, like this is the resultant vector and it is having some theta, that direction theta is equal to tan inverse of ay divided by ax. So this theta will be equal to tan inverse of, as ay is equal to ax, we can write it tan inverse of 1, that will be equal to 45 degree. So now we will take this in the form of directions, that is this direction is north, this is south, this is west, and this is east. Our average acceleration magnitude is in this direction, that is equal to 1 by root 2 meter per second square, and this angle theta, so theta is equal to here 45 degree. So our answer will be 1 by root 2 meter per second square. This is the magnitude of average acceleration, and the direction of this average acceleration will be northwest direction, that is northwest direction. Okay, now coming to the third question. So our third question is, a particle moves in a circle of radius r. In half of the time period, half of the period of revolution, its displacement and distance covered. Okay, so the particle is moving in circular motion like this. Let us suppose the radius of this circle is r. Okay, now for half of the period of revolution, let us suppose this is the initial point A and this is the final point B, and in half of the revolution this particle will be moving from point A to point B in this direction, let us suppose. Then distance traveled by the particle will be distance. So since from the definition of distance is the actual path covered by the particle, actual path. Okay, so that actual path will be equal to the circumference of the circle divided by 2, that is equal to pi r. So this is the distance traveled by the particle. Okay, and displacement traveled by the particle will be displacement, and displacement traveled by the particle is the minimum distance between the initial and final point, that is equal to 2r. So this will be the displacement, 2r. So 2r. So this will be the displacement. So this is an easy question asked in JEE Advanced. Now coming to the fourth question. Fourth question is what? We have to comment on the graph. A graph is given between the time and distance, time and position or distance traveled by the particle. So this is the time and this is the position x. The graph is given like this. Okay, we have to comment, is the time variation of the position shown in the figure observed in nature? So we have to tell this graph is correct or not. So from the given graph we can easily see that at a given time, like at this time, if we draw a line parallel to the x-axis, so at a given time, like at given time t naught, there are two positions, one is A and one is B. So this will be, let us suppose, x1, this is x2. It can never be possible that at a single given instant of time particles is at two different positions. So this will violate the laws of physics. So we cannot say like this that at a single time particle is having two different positions. So this graph is not correct. So graph सही नहीं है. So graph is not correct. So our answer will be no. Okay. Now coming to the fifth question. Our fifth question is, the velocity displacement graph of a particle moving along a straight line is given. Okay, so velocity displacement, okay, so graph is given, that is velocity displacement graph, that is straight line graph. So this position is v naught, this is x naught. Okay, this is origin. What we have to tell, we have to draw the graph of acceleration and displacement. Okay, so first of all we should know that how to write the equation of straight line that is given in the graph. So by using the equation y is equal to mx plus c. What is this m? Here m is the slope, that is equal to tangent theta. So this is the theta, and tangent theta we have to write. Okay. C is the y-intercept, that is equal to v naught, and in y-axis v is given, x-axis x is given. So we can write from here the equation of the velocity and x. V is equal to, that slope will be negative because theta is greater than 90 degree, negative of v naught divided by x naught dot x plus, here y intercept is positive, so we will be having plus v naught. So this is the equation of line drawn in this graph between the v and x. Okay, now we know that at the acceleration is defined as dv by dt, and also the acceleration is defined as v dv by dx, v dv by dx. So from this equation we can calculate what is the dv by dx. So dv by dx will be equal to negative of v naught by x naught plus 0. So dv by dx we can dv minus v naught by x naught. Now we can put the value of v and dv by dx from this equation to this equation. That acceleration we will be getting is v is negative of v naught by x naught x plus v naught into negative of v naught by x naught. So we'll be getting a direct relation between the acceleration and the displacement, that is equal to v naught square by x naught square dot x minus v naught square by x naught. Okay, so this is also a straight line drawn between the acceleration and x, which is having positive slope but negative y-intercept. So comparing with the y is equal to mx plus c, here c is negative, m is positive, we will draw the equation of line between the acceleration and the displacement. That will be the acceleration and this will be the displacement. So our line will be like this. Okay, so here this will be the slope theta, that is equal to tangent theta. Here tangent theta will be equal to v naught square by x naught square, and this will be equal to the y-intercept, that will be equal to v naught square by x naught. Okay, so this will be the most suitable acceleration and displacement graph for the given velocity and displacement graph. Now coming to the next question, the question number 6. So our sixth question, another graph is given. The graph is given between the acceleration and the time. Okay, so graph is given like this. This is the acceleration, this is the time. This is origin at t is equal to 0. particle is moving like this. So this is the 10 here and this is the 11 seconds. What we have to tell, a body starts from the rest at t is equal to 0. Okay, so at t is equal to 0, it is given that initial velocity is also equal to 0. Okay, as shown in the figure, the maximum velocity attained by the body will be, so we have to tell what will be the maximum velocity attained by the body. Since we know that from the Newton's equation of motion, v minus u is equal to at. So from this graph, what we will draw the conclusion is the area under AT graph gives the change in velocity. So this is always true that v vector minus u vector is equal to a vector dot t. The area under the acceleration time graph always gives the net change in the velocity. Okay, so this is the area under this graph. So what will be the area under this graph? That will be equal to, area is equal to half into base into height, that is equal to 10 from this triangle, 5. So area will be equal to 55. Okay, now we will use this equation, v minus u is equal to area under AT graph. So here u will be 0, so this term will be cancelled out and we will be getting the final velocity, that is equal to area under the graph, that is equal to 55 meter per second. So this is the maximum velocity attained by the particle in this motion. Okay, now coming to the 7th question. Seventh question is given as a car accelerates from the rest. Okay, so this is also JEE Advanced subjective type question. A car accelerates from the rest at a constant rate alpha for some time, after which it deaccelerates at the constant rate beta to come to rest. If the total elapsed time is t seconds, we have to calculate the total distance traveled and the maximum velocity reached. Okay, the question is simple, but we will be solving it in some less time with using some different tricks or using the basic concepts, we can say. So let us pause. The situation given in the question is, particle is moving from point A to point B, point A to point B, and for particular interval of time, let us suppose t1, it is accelerating with a rate of alpha and total time elapsed is given as the t seconds. So this time period will be t minus t1. Okay, so that will be equal to t2, and for this time period the particle is deaccelerating with a rate beta, and we know that here particle initial velocity is also 0 and the final velocity is also 0. Now we have to solve. For this time period, we can apply the equation of motion, that is, let us suppose here the velocity is v, that will be the maximum velocity only. So v is equal to u plus alpha t1. Here u is 0, so we will be getting this maximum velocity v maximum is equal to alpha t1. Let us pause. This is the equation 1. From this equation 1 we can draw that t1 is equal to v maximum divided by alpha. So this is the equation 1. Okay. So we can also write the same equation for this given time period. Here particle is deaccelerating with the rate beta. So here v final, that is equal to v minus u is equal to at. The equation we will use here, v final is 0 and this v maximum will be the initial velocity now, that is equal to v maximum equal to what will the rate of deacceleration here is negative of beta into what is the time t2, that is equal to t minus t1. So t minus, we will put the value of t1 here, that will be equal to v maximum divided by alpha. Okay. Now what we have to do, we have to just solve these equations. So let this will be the cancelled out. So Vm divided by beta plus V maximum divided by alpha, that will be equal to beta into t. Okay. So what we have to calculate, V maximum alpha plus beta divided by alpha beta, that will be equal to beta into t. So we got V maximum is equal to beta into t into alpha beta sorry, this term we missed here. This Vm we can take common, so this beta will not be there, we have taken it in this side. So Vm alpha plus beta divided by alpha beta, that will be equal to t. So we will be getting V maximum attained by the particle is alpha beta into total time t divided by alpha plus beta. Okay, now we have gotten the relation between the velocity V maximum and this time period. Now since it is a motion in which particle is accelerating with a constant rate and also deaccelerating up to some time, we can draw the graph between the velocity and this time. So this is the velocity, this is the time. We can directly say that for particular interval of time, this particle is accelerating, and here particle attains the maximum velocity, that is Vm. So this is the Vm at some interval of time, that is equal to this time period is t1 and this time period is t2. Now what we have to calculate, the total distance traveled by the particle. Total distance traveled by the particle. Okay, so total distance traveled by the particle will be equal to the area under the VT graph. So total distance traveled will be equal to the area under VT graph. Okay, so what will be the area under this VT graph? This is the V maximum, and the value of V maximum we already know. The area will be for this triangle half into base, that is t, multiply height, that is equal to v maximum, that is equal to half of t dot alpha beta t divided by alpha plus beta. Okay, so this is the total distance traveled by the particle. Total distance traveled is equal to half alpha beta alpha plus beta into t square. So this is our answer. We could also solve this question for the total distance by using the equations of motion, but that will be a longer method. We can directly calculate by using this graph method. Okay, now the next question is, okay, that aeroplane question it is. This is a good question. Next question is 8th question. Here firstly we will read the statement that aeroplanes A and B are flying with constant velocity in the same vertical planes at an angle 30 degree and 60 degree. Okay, so it is given that these are the two aeroplanes. We will draw the diagram. This is A, this is B, and the aeroplane A is moving at an angle of 30 degree. So let us put this is moving in this direction, that is 30 degree, and this B aeroplane is moving in this direction at an angle of, okay, at an angle of 60 degree. Now what we have to do, the speed of A is, okay, the speed of A is given, that is equal to v is equal to 100 root 3 meter per second. Okay, at t is equal to 0, an observer in A finds B at a distance of 500 meter. Okay, the observer sees B moving a constant velocity perpendicular to the line of motion of A. Okay, and at t is equal to t naught, A just escapes being hit by B. So what is the value of this t naught second? Okay, I will tell you the statement given in the question. At some instant of the time, A observes B. So this is the line of motion of B, and this is the line of motion of A. He observes that B is moving along the line perpendicular to the line of motion of A. So A is moving in this direction, so he is observing that B is moving along this line. Okay, so distance also given, that d is equal to 500 meter. It is given between these two aeroplanes A and B. So we will use the concept of relative velocity here. We will resolve the velocities of this B in the direction of A and the direction perpendicular to the B. Okay, so this is the 90 degree angle, and this angle, let us suppose this will be the 30 degree, so this also will be the 90 degree angle. So this angle will be 30 plus 30, so this angle will be 30 degree. No, this angle will be 60 degree. Okay, so let us suppose the velocity of VB is VB. So the velocity that is in the direction perpendicular to the line of motion of A will be VB, cos 60 degree. Okay, and the velocity that is parallel to the A is VB sin 60. Since in the statement given in the question, it is clearly written that observer sees B moving with a constant velocity perpendicular to the line of motion of A. Okay, so here that B from observation done from A, B is moving along the line perpendicular to the line of motion of A. That means इनके पैरेलल में जितनी भी वेलोसिटी होगी वो इक्वल होगी. So the velocity of A, if I suppose that this is the coordinate system I am defining, so this is the x-axis and this is the y-axis. So VA I can write 100 root 3 meter per second I cap, and VB I can write same, that will be equal to some amount like VB vector I am writing, that is equal to VB sin 60 I cap. Since there is not any motion perpendicular to these, so parallel to these, so their velocities will be equal in this direction of motion. So I can write VB sin 60 degree will be equal to VA, that is equal to 100 root 3. So from here VB dot sin 60 is root 3 by 2, that will be equal to 100 root 3. So root 3 will be cancelled out and we will be getting VB is equal to 200 meter per second. So now we can clearly write the velocity perpendicular to the line of motion, that is equal to VB cos 60, that is the V perpendicular is equal to 200 multiply 1 by 2, that is equal to 100 meter per second. Okay, since it is given that the distance between the two particles at this instant is 500 meters. Okay, so from any frame being observed, we know that the distance between the two particles will be same, whether in accelerated frame or some frame. It does not depend on any frame, the individual distance between the two particles. So now we have to tell at what time they will meet. So this V perpendicular will only be responsible for the meeting of these two particles because these velocities are equal. So इनकी वजह से तो ये दोनों planes कभी मिलेंगे ही नहीं. So ये वाली velocity ही इनको मिला सकती है. यहाँ पे distance given है 500 meter, that is equal to 500 meter. So time taken to meet, that is equal to T naught will be equal to distance divided by this velocity, that will be equal to V perpendicular velocity, that is equal to 500 divided by 100. This is equal to 5 seconds. So T naught will be equal to 5 seconds. So this is our answer. Okay, now question number 9, it is a statement based question. We have to tell which statement is true and which is not true. So here for an statement 1 is given, for an observer looking out through the window of a fast moving train, the nearby objects appears to move in opposite direction to the train, while the distant object appear to be the stationary. Okay, so we will consider the situation like this is the train and we are sitting here. So we are the observer, I am the observer here. Okay, and this is a, let us suppose two poles are there or two trees are there. I'm supposing that poles are there. This is the pole P1. It is nearer to this train, and this is a pole P2. So this pole P2 is somehow at a large distance from the train, and this train is moving with the velocity v. Now I have to observe these two poles. What will I see? Sorry. So what will I see is, for pole P1, let us suppose this is the distance d1, and for P2 it will be a large distance d2. Okay. Now I am the observer. If I observe this pole P1 from this train, then I will see that this pole is moving with velocity v, that is equal to the velocity of train in backward direction. And same with the pole P2. Pole P2 will also be observed that it is moving with velocity v in backward direction. Okay. Since I will use the concept of that angular velocity from this point O where I am sitting. What will be the angular velocity of this pole P1? So angular velocity of this pole P1 will be equal to velocity v perpendicular divided by this radius. So this is the formula we will discuss later. I am just introducing here. This angular velocity is the velocity that is perpendicular to this radius line joining divided by the radial length. So this v perpendicular is v divided by d1. And similarly, angular velocity of this point P2 for reference with this observer is v divided by d2. Since d2 is very greater than d1, we can say that omega of this pole P2 is very less than omega of this pole P1. So like I am sitting here at this point O inside the train. जब मैं पोल P1 को देखूँगा तो मेरे को बहुत फास्ट नेक को रोटेट करना पड़ेगा. And for pole P2, since angular velocity is low, so मेरे को काफ़ी टाइम तक दिखेगा ये. So the statement given in the question is, the nearby objects appear to move in the opposite direction to the train while the distance objects to be stationary. So इनका एंगुलर वेलोसिटी इतना कम हो जाता है अगर मैं d को बहुत ज़्यादा इंक्रीज़ कर दूँ. इफ़ d2 tends to infinity, then this omega p2 for pole P2 will be nearly equal to 0. That means वो स्टेशनरी दिखेंगे, उनका कोई एंगुलर वेलोसिटी नहीं होगा. Okay, so this statement is true. The distant objects appear to be nearly stationary. Sorry. Now statement 2 is given. If the observer and the object are moving at velocities v1 and v2 vector respectively with the reference to a laboratory frame. Sorry. Laboratory frame, the velocity of the object with respect to the observer is v2 minus v1. Okay, it is incorrect statement actually. What he is saying, there are the two objects, like object 1 moving with velocity v1 and object 2 is moving with v2 with v2. In the laboratory frame it is given. So this is the laboratory frame in which these two particles are moving. Now what they are saying is, the velocity of the object with respect to the observer is v2 minus v1. No, our observer is sitting here in the laboratory frame, so velocity will not be equal to, because laboratory is at rest now. So velocity of laboratory is 0, so we cannot say that the velocity of the object with respect to the observer is v2 vector minus v1 vector. So it is incorrect. velocity will be same only since the laboratory is not moving. Okay. So our next question is the question number 10th. Okay, it is a good question. Question number 10. It is a good question. 4 persons K, L, M, N are initially at the four corners of the square of side D. Each person now moves with a uniform speed V in such a way that K always moves directly towards. Okay, I will draw the diagram first. This is the distance D. This is a square. 4 persons K, L, M, N. So at some instant of time, K starts moving with velocity V towards L, and L starts moving with velocity V towards M, and M starts moving with velocity V towards N, and similarly N starts moving with velocity V towards K. Okay, we have to tell at what time they will meet. So after some time this particle will be like here, and this particle will be here. Its velocity will be like this will be like this will be like this, and this will be like this. So it will be following a path, and they will meet at the center of this square. So we don't have to use so many equations to solve this question. It is a direct question actually. I will consider the two particles here, that is K, and this is the particle L. Particle L is moving with velocity V in this direction, and K is moving in this direction with velocity V, and distance between them is D. Now as we have solved in the previous question, that airplane problem, this velocity will only be responsible for the meeting of these two particles. This velocity will always take the particle L away from it, so we cannot take this. So this velocity will always be responsible in this direction to meet the particle. So what will be the time required here? That will be equal to D divided by V. Okay, so this is the only time that will be required for these all the particles to meet. So we can apply this concept at any situation. Also for the different diagrams we can apply this formula, this concept. This is useful concept actually. So this is the time required for these particles to meet. Now question 11. Two balls of different masses are thrown vertically upwards with the same speed. They pass through the point of projection in their downward motion with the same speed. Neglect the air resistance. Is it possible? Okay. So let us suppose this is the surface, and this is a particle of mass m1, and this is a particle of mass m2, and we are throwing this with same initial velocity, that is equal to u. Okay, so the motion of these two particles will be like this. They will go up and they will come down. They will go up and this will also come down. Since if I take g is equal to constant, so the acceleration of both the particles m1 and m2 will be in downward direction, that is equal to g. So here will be the velocity 0, that is equal to v is equal to 0, and here will be some velocity. So for particle 1, if I write the equation of motion, that that v is equal to u plus at, not v is equal to u plus at, we have to use third equation of motion here, that is equal to v square minus u square is equal to negative of 2g into some height h. So they will be moving up to the same height only, because the initial velocity is same. So here final velocity will be 0 for the first half of the motion. So height, let us suppose it is u square by 2g. So from this height, now this particle's velocity, initial velocity will be 0. So similarly v square minus u square is equal to 2gh. So v square will be equal to, this will be 0, 2 into g into what is the height, that is equal to u square over 2g. So v will be equal to u only for both the particles, we will calculate. Similarly for this particle, at this point v will be equal to u. So we can say that this statement is correct only, that both the balls will be having same velocity when they pass through the point of projection. Okay, so this is the end of our session, the questions from the kinematics part. In the next video I will be uploading the questions, some good questions from the kinematics and the 2D plane motion. Okay, thank you.